Breathwork as a biological technology, oxygen CO, and nervous system regulation. Breathing is often taken for granted, an automatic process that occurs without thought. Yet breath is one of the most powerful tools for regulating human energy, physiology, and emotional state. It is both an involuntary reflex and a conscious tool that can influence the autonomic nervous system, hormonal balance, oxygen delivery, carbon dioxide levels, and cellular metabolism. Breathwork, the deliberate practice of controlling inhalation, exhalation, and retention functions as a biological technology, allowing humans to optimize energy, resilience, and mental clarity in ways that were once considered beyond conscious control. At its most fundamental level, breath regulates oxygen O delivery to tissues and carbon dioxide CO removal, two gases that are critical for cellular energy production. Oxygen is essential for oxidative phosphorylation in mitochondria, the process that converts nutrients into ATP, the energy currency of the cell. Without sufficient oxygen, cells shift to less efficient anaerobic metabolism, producing lactate and causing fatigue. CO, often overlooked, plays an equally important role. It regulates blood pH, influences hemoglobin's affinity for oxygen through the Bohr effect, and modulates vascular tone. Breathwork allows conscious modulation of these gases, directly influencing metabolic efficiency, tissue perfusion, and systemic energy. The autonomic nervous system, which governs the balance between the sympathetic fight-or-flight and parasympathetic rest and digest branches, is tightly coupled to breathing patterns. Slow, deep, diaphragmatic breathing stimulates the parasympathetic nervous system via the vagus nerve, reducing heart rate, lowering cortisol, and promoting relaxation. Rapid or shallow breathing activates the sympathetic nervous system, increasing alertness, readiness, and metabolic rate. By mastering breath, humans can shift their physiological state on demand, calming stress, enhancing focus, or increasing alertness and performance. Breath becomes not merely a life-sustaining reflex, but a tool for energy optimization. CO₂ sensitivity is a key mechanism through which breathwork affects physiology. Many people chronically overbreathe, lowering CO levels in the blood. Hypocapnia. Low CO reduces cerebral blood flow, constricts blood vessels, and impairs oxygen delivery despite adequate oxygen intake. This paradox, hyperventilating yet experiencing fatigue or dizziness, is common in modern lifestyles dominated by shallow chest breathing. Techniques that emphasize controlled breath retention or slower exhalations increase CO, improving oxygen, offloading in tissues, and enhancing cellular energy production. Breathwork, therefore, is a precise method to manipulate the oxygen-CO balance for maximal physiological efficiency. Breathwork influences heart rate variability, a marker of AN's flexibility and overall health. High HRV indicates a resilient system capable of adapting to stress and maintaining energy homeostasis, while low HRV is associated with fatigue, stress, inflammation, and disease risk. Slow, rhythmic breathing synchronizes heartbeats with respiration, a phenomenon called respiratory sinus arrhythmia. This synchronization enhances vagal tone, stabilizes blood pressure, improves digestion, and reduces perceived effort during physical activity. Through conscious breathwork, individuals can optimize HR, effectively training their nervous system to maintain higher baseline energy and resilience. The interplay between breath and emotional state is profound. Anxiety, anger, and panic often manifest as rapid, shallow, irregular breathing. Conversely, controlled breath techniques such as box breathing, alternate nostril breathing, or diaphragmatic pacing signal safety to the nervous system, modulating the HPA axis and reducing cortisol. Emotional energy, often experienced as mental fatigue, tension, or irritability, is directly influenced by breathing patterns. Mastery of breath allows regulation of emotional states, improving clarity, focus, and productivity, while reducing the physiological energy drain caused by chronic stress. Breathwork also impacts mitochondrial function. Oxygen is the final electron acceptor in the electron transport chain. An efficient mitochondrial respiration is dependent on adequate oxygenation at the tissue level. Breath techniques that optimize oxygen delivery, enhance ATP production, reduce lactate accumulation, and improve endurance. This effect is particularly relevant for athletes, laborers, and anyone engaged in sustained physical or cognitive activity. Moreover, increased CO levels from controlled breathing improve microcirculation and oxygen offloading, creating a metabolic environment in which energy is maximized. Practical breathwork techniques demonstrate how conscious control can alter systemic physiology. Deep diaphragmatic breathing engages the lower lungs, increases venous return, stimulates the vagus nerve, and reduces sympathetic overactivation. Alternate nostril breathing balances autonomic input, modulates cortical activity, and promotes mental clarity. Box breathing, with equal phases of inhalation, hold, exhalation, and hold, stabilizes heart rate, enhances focus, and improves resilience to stress. Retention techniques, practiced safely, elevate CO, optimize oxygen delivery, and enhance endurance. These practices are not abstract. They produce measurable changes in blood gases, hormone levels, HRV, and mitochondrial efficiency. Breathwork has profound implications for recovery and sleep. Slow, deep breathing before sleep activates parasympathetic dominance, lowering heart rate and preparing the body for restorative cycles. Adequate oxygenation during sleep supports cellular repair, hormonal restoration, and brain detoxification through glymphatic flow. Conversely, disrupted breathing patterns, such as those seen in sleep apnea or chronic shallow breathing, impair sleep quality, reduce energy restoration, and increase inflammatory signaling. Breathwork is therefore a tool not only for daytime energy optimization, but also for nocturnal recovery and long-term resilience. Integration with physical performance amplifies the benefits of breath. Controlled breathing during exercise enhances oxygen utilization, delays fatigue, and improves endurance. Techniques such as rhythmic inhalation-exhalation during running or resistance training maintain CO balance, reduce lactic acid buildup, and improve overall metabolic efficiency. Breathwork also improves coordination between muscular effort and autonomic regulation, reducing perceived exertion and increasing sustainable energy output. Athletes, performers, and professionals can harness breath as a biological technology to push boundaries safely and efficiently. Breathwork influences cognitive performance and mental energy. Oxygen delivery, CO balance, and autonomic modulation affects cortical activity, neurotransmitter synthesis, and synaptic function. Students, professionals, and creatives who incorporate conscious breathing techniques experience enhanced focus, reduced mental fatigue, and improved decision-making under pressure. Brain energy is optimized through both chemical oxygen and CO and neural autonomic regulation pathways, illustrating that breath is a direct interface between mind and body. Hydration and nutrient status intersect with brain. Oxygen transport depends on hemoglobin, which requires iron, vitamin B12, and folate. Mitochondrial respiration is magnesium dependent, while electrolyte balance supports muscular and neural responsiveness. Breathwork is therefore most effective when integrated with comprehensive nutritional and hydration strategies, creating a systemic environment in which oxygen, CO, and cellular metabolism are fully optimized. Aging and resilience are influenced by breath patterns. Chronic stress, shallow breathing, and autonomic imbalance accumulate over decades, reducing HRV, oxygen delivery, and mitochondrial efficiency. Breathwork interventions can partially reverse these trends, improving energy, mental clarity, cardiovascular health, and immune function. The nervous system remains plastic, and targeted breath training is a non-invasive, scalable, and highly effective strategy for sustaining vitality across the lifespan. In conclusion, breathwork is far more than a relaxation technique. It is a biological technology that directly controls oxygen delivery, CO levels, autonomic balance, mitochondrial efficiency, hormonal regulation, cognitive function, and emotional energy. Properly applied, It enhances physical performance, mental clarity, emotional stability, and systemic resilience. Breathwork allows humans to consciously manipulate internal physiology, optimizing energy for both acute performance and long-term vitality. By understanding and mastering this fundamental mechanism, energy is no longer a passive outcome, but a deliberate, trainable capacity. Breath is life, and deliberate breath is vitality engineered at the cellular, neural, and systemic levels.